Welcome back to The Explainer. I'm absolutely thrilled you're here today because, well, we're tackling something huge. We are diving into one of the most high-stakes, fiercely debated, and, honestly, notoriously tricky topics in the entire Cambridge 9709 syllabus. Yep, we're talking about vector geometry. Now, whether you're an A-level candidate who's laser-focused on locking down that top-tier grade, or you're just someone fascinated by how examiners rigorously test mathematical minds, this explainer is going to be a real game-changer for you. We're going to decode exactly what the examiners actually want to see from you, specifically when it comes to the scalar product, finding the angle between lines, and, of course, that elusive foot of a perpendicular. So let's jump right in, shall we? So here's a wild question. Why are vectors considered the single most misunderstood area in mathematics? It sounds like a bold claim, right? But honestly, if you read the principal examiner reports, it is absolutely true. Year after year, concepts like calculating the scalar product, figuring out the exact angle between 3D lines, or finding the foot of a perpendicular, they just act as massive stumbling blocks. And the crazy thing is, these specific areas consistently trip up even incredibly strong candidates. It's actually not because the arithmetic itself is impossibly hard. It's usually because students completely misunderstand the underlying geometric relationships and what the examiner is actually asking them to demonstrate. But hey, that's exactly what we're going to fix right now. To get us to that top grade, we've got a 4-part examiner's playbook for today. We'll start with theoretical foundations, move into our procedural framework, look at critical analysis, and finish up with some crucial examiner warnings. All right, first up, Section 1, Theoretical Foundations. Let's look at the cognitive architecture behind high-level vector math. What's genuinely fascinating here is how the assessment objectives are actually broken down. Cambridge examiners, they aren't just checking to see if you memorized a formula. They are actively targeting 3 distinct cognitive domains. First, you've got basic knowledge and understanding. Like, do you literally know the formula for the scalar product? Simple enough. Then comes the second domain, application. Can you actually use that formula to find an angle in a given problem? But here is the kicker, the third domain, analysis. This is where the top marks live. Analysis means truly understanding the causal relationships between geometric features in 3D space. It goes far, far beyond rote memorization. You really need to prove you grasp the precise definitions governing these spaces. And this brings us to a massively important insider insight. This is a direct quote from the Principal Examiner Report, and it states, candidates referencing cross-topic connections achieve significantly higher marks. This is literally the secret to unlocking those top-tier grades. The takeaway? Vectors do not exist in a vacuum. The absolute best candidates naturally integrate their vector knowledge with other areas of the syllabus, things like trigonometry or calculus. If you can show the examiner that you see the mathematical big picture, I promise you, your marks are going to skyrocket. Which brings us nicely to Section 2, the procedural framework. Because knowing the theory is great, but capturing the marks on the actual page is what it's all about. To systematically capture those marks, we need a foolproof execution strategy. Think of this 5-stage sequence as your personal roadmap. You should probably memorize it today. When you're staring down a vector question, first, deconstruct the question. What exactly are the command words asking you to do? Second, extract the relevant data from the noise. Third, select your analytical framework. Ask yourself, am I using a dot product here, or do I need to set up parametric equations for a line? Fourth, execute the math with exceptionally clear notation. And finally, fifth, present your final answer using the correct mathematical terminology. Stick to this standardized sequence, and you ensure absolutely 0 marks are left on the table. Now, you might be wondering, why is that 5-step process so absolutely crucial? Well, it's all about the method mark strategy. The examiner reports make this undeniably clear. They reward your systematic process and your clear analysis just as much, if not more, than that final numerical answer. Think about it. If you happen to mess up a tiny bit of basic arithmetic at the very end, but your working is pristine, your headings are proper, your formats are correct, and your annotations prove you knew exactly how to find the foot of that perpendicular, you are still going to capture the vast majority of those method marks. So the golden rule? Never, ever do complex vector calculations entirely in your head. Put it on the page. All right, let's keep the momentum going. Section 3, Critical Analysis. Let's talk about how to elevate your answers from just good to A-star territory. I want you to look at the stark contrast between these two approaches. A basic level candidate is just going to identify the given info and solve it systematically. And hey, don't get me wrong, that's fine. It gets you passing marks. But an evaluative level candidate, that's your top scoring student. They do something entirely different. They show higher order evaluative thinking. They question assumptions, they actually check their final answers to see if they're reasonable, and they justify their decisions with hard evidence. For instance, if you calculate an angle between two intersecting lines, an evaluative thinker will take a split second to verify if that resulting angle makes logical, geometric sense within the coordinates they were given. They don't just spit out a number, they justify why that number is valid.
Okay, we've arrived at arguably the most critical part of our explainer. Section 4, Examiner Warnings. This is high-stakes stuff directly from the people holding the red pens.
The examiners have specifically flagged 3 massive traps that candidates fall into year after year. Trap number 1, confusing cause and effect. In vector geometry, if line A is perpendicular to line B, then their scalar product is 0. You have to clearly state that exact cause and effect relationship in your logical steps. Trap number 2, forgetting format and presentation checks. Look, writing vectors out as simple coordinates without column format or proper IJK notation, or, and this happens all the time, forgetting the degree symbol on your final angle, that literally bleeds easy marks. And trap number 3, providing generic answers that completely ignore the specific context of the question. Let's look at a concrete example of how that last trap plays out. Say a question asks about the vectors of 2 specific aircraft flight paths. A generic answer is just going to say something like, the lines don't intersect. But a context-specific answer, that candidate writes, because the directional vectors are not multiples and the position vectors do not yield a valid intersection point, aircraft A and aircraft B will not collide. Do you see the difference there? It's huge. You must constantly link every single mathematical point you make back to the specific scenario provided. That, right there, is how you lock in top marks. So let's quickly recap what we've unpacked today. If your goal is to truly master Cambridge 9709 vectors, you need to nail these 3 things. 1. Integrate your cross-topic knowledge to prove you understand the wider mathematical foundations. 2. Strictly follow that 5-step execution framework. Deconstruct, extract, select, execute, and present. So you capture every single available method mark. And 3. Always link your final evaluation directly back to the specific context of the question. Which brings me to one final, slightly provocative question for you to chew on before your next exam session. When you sit down at that desk and you're faced with a highly complex vector problem involving scalar products and perpendicular lines, are you just punching numbers into a calculator and hoping for the best? Or are you executing a carefully structured high-level examiner strategy? I really challenge you to rethink your approach starting today. Apply this exact blueprint we've discussed and just watch how your understanding and, for sure, your grades completely transform. Thank you so much for joining me on this explainer, and keep up the great work.